So let's begin with the next topic, that is lecture 6, and the topic is stack in 8051 microcontroller. We'll see what is stack pointer. The stack is a portion of RAM used by the CPU to store data or memory address on temporary basis. The information may be either data or an address that can be stored in a part of RAM, and that part is called as stack. And the register used to access that stack is called stack pointer. This SP is 8-bit register and it can take value from 00H to FFH ideally, but it starts from 07H practically. The RAM memory location 08 is the first location used for the stack by stack pointer. Remember, whenever 8051 is reset or powered on, the SP will contain by default address 07H. Loading data from CPU onto the stack is done using push operation, and loading the content of stack back to the CPU, that means reading from stack, is called as pop operation. So SP is incremented before pushing operation and decremented after pop operation. So we can say SP is 8-bit register, which means it can take value from 00H to FFH. It always point to the last used location. The SP stores address of the top data. It points to the last used location. Here you can see SP is having data 07 in the beginning, but whenever we want to add some data in stack, it will first increment SP by 1 and the data is loaded. So stack elements are added only from the top, and it is called push operation. And whenever we read data from stack pointer, it is called pop. And whenever we pop something from stack, that will be deleted automatically. So we can either add or we can delete the data in stack. So adding is called push, and deleting something from stack is called as pop operation. So you can see example here. Initially the stack is empty, so first data is entered in stack, that is called as push operation. Then second element is added in stack using push operation. Then third is added in the stack using push operation. When something is taken out, so last was this red color element that is popped by the stack pointer. So here we have only two elements. Then yellow is removed from the stack, or you can say popped, so only one is remaining, and this can be removed at the end. So the data added at the last will be popped first, that is called as last in first out type. So as I told, whenever 8051 is powered up, the SP contains value 07. This means that the RAM location 08 will be the first location used for the stack by the 8051. So whenever we reset the 8051, the SP will be having value 07, and we can add first number at 08, then second number at address 09, third number at address 0A, B, C, and so on. So let's see how push operation is here. Initially the SP is equal to 07. So first data will be stored at location 08. For that SP is incremented by 1 and then data is pushed. Say example, we are storing data AAH, 44H, CCH and 11H in stack. So this works in this way. First of all, SP is incremented from 7 to 8 and the data AA is added. First element is added in stack. Then again SP is incremented by 1 and data is added at address 09H. So we have first second element 44 in stack. To add third one, again increment SP by 1. So 9 plus 1 equal to 0A. And here we have the third element. So first element at address 08, second at address 44 and third at address 0A. And the fourth element is stored at address 0B by incrementing by 1. So here we have data AA, 44, CC, 11 in stack. Now so we have last data stored at address 0B. Let's see how pop 1. The pop will first take the data and decrement SP by 1. So see here we have data at 0B is 11. So SP will read data 11 and we will point to next. So decrement by 1, so we'll be pointing 0A. So 11 is deleted or we can say popped. In next step, both elements are decremented, deleted, so SP is pointing 09 and for next we have SP will point 88 and AA, the third element is also removed. In this way, for pop, read data and decrement the pointer by 1. In case of push operation, increment SP by 1 and then add the data. So that's all for this stack operation. If any queries, please contact me on the mail given below.